Hello. Today I want to start a kind of like a mini series of 3 videos, and in my head they're very connected, although it might not appear as such at first. First, I want to talk about plasma surface modification. Then I'll move on to how people measure plasma surface modification, and then I'll talk about water and what crazy fascinating liquid it is. Anyway, hello, my name is Greg Friedman. Welcome to the channel. If it's your first time here, well, of course, subscribe and like and comment. But this channel is about chatting about science. My specialty is electric discharges, plasmas, but I talk around and around similar topics. Well, anyway, today I want to talk to you about plasma modification of surfaces, how plasmas are used to modify the very, very thin layer of the surface without changing bulk properties of the whole material. So the basic idea here is you have material that you've engineered to have some very specific bulk properties, like you have a big steel rod and you want it to have exactly the properties that it has, but you want it to be a different color. So just, paint the surface. You want the paint to stick to the surface, but whatever glue or whatever treatment method you use for that, you don't want it to change bulk properties. And plasma is good at that. For many, many applications, not just painting steel, but painting clothing and lots of different surface treatments, you want bulk properties to stay the same. You just want changes at the interface. And plasma is perfect for that. Plasma creates very reactive environment that can affect the surface, and you can even control what happens at the surface and the depth to which plasma can penetrate. Plasma can change, or plasma surface modification can change wettability, adhesion, biocompatibility, surface roughness, lots of different surface properties of the material, but the bulk, I can never say that enough. It's the same part, just the surface is different, so the bulk properties are the same. So what does plasma do to the surface? Oh gosh, it depends on the plasma, it depends on the surface, of course. But in general, you're able to clean surfaces. So for example, you have oils, oxide layers, like, if you take a piece of metal, you're actually looking not at the metal, you're looking at the metal oxide. There's virtually no such thing as raw metal on Earth. There's oxygen, and metal will very quickly oxidize and become covered with a thin layer of, you have a titanium rod, well, it's titanium oxide you're looking at. Or you have a copper rod, well, it's copper oxide. The question is how much of that oxide? Anyway, plasma treatment can remove that layer of oxide. It can remove oils, residues, dust, dirt, etc. It can activate the surface by adding functional groups, especially in polymer materials. You have carbon, hydrogen, plasma can come in, oxygen, plasma can come in, and put OH groups in a surface that are very reactive, and that makes that surface much easier to paint, much easier to adhere things to. Plasma can also damage the surface a little bit. You might want that. You can do surface modification, creating texture. And that texture can make the surface easier to wet or maybe harder to wet in certain situations. Biocompatibility of the surfaces. There's a lot of work that I participated a little bit in that was done for blood compatibility of tubing with plasma. So the surface was modified in such a way that blood cells, specifically platelets, would have difficult time attaching to that surface, so you're reducing possibility for blood clotting on this foreign material that's introduced into the body. You can cross-link the surface layer. if such is desirable. There's very interesting work in using plasma to create micropores in thin polymer membranes, and that's used for filtration. So lots of different applications in plasma surface modification. You can even add things to plasma, so you can deposit coatings. And also, a lot of things depend on what gas environment you're in. You can create reducive environment or oxidative environment. You can create environment with lots of atomic fluorine, like if you run with SF6 as the gas that plasma is generated in. Then you can deposit fluorine on the surface, making the surface rather hydrophobic, so water does not attach to it as much. Or you can run in nitrogen and put nitrogen groups on a surface. Nitrogen with a couple of percent hydrogen, you'll have amine groups on the surface. And now you can do wet chemistry to permanently bond things to that surface. Like, for example, you can take a metal implant, cover it in plastic for protection and for improvement of various biocompatibility processes, and then put amine groups on the surface of that polymer and covalently bond, permanently attach antibiotic to that. And now your implant is permanently antibiotic. Pretty cool, huh? So I know I touched on some of the industrial uses of this, but in general, industry uses plasma coatings to improve bonding of inks and glues and paints and coatings and adhesives. Car industry, lots of parts in your car are plasma treated before you glue two things together. Plasma is widely used to make polymer surfaces more wettable, specifically for gluing, attaching, painting, and those kinds of applications. You can think of many applications in packaging, electronics, medical device manufacturing, different kinds of composite materials. Everything is surface on surface, and surface texture, surface roughness, surface wettability, they all are quite important. Imagine an iPhone that would never leave a fingerprint. Yes, that's possible. One of the things that's not often talked about is switching to plasma reduces your reliance on wet chemistry. So back in the day, you wanted something on the surface. Well, you take your material, you dip it in acid, you dip it in something else, you dip it in something else, and then you dip it in ink. Now, most of this process can be dry or almost dry, so that creates for safer, more environmentally friendly treatments. So plasma surface modification is a field that's definitely on the rise, and if you're just starting your journey, studying plasma surface modification is something that you definitely should consider doing. And with plasma treatment, everything depends on everything. Gas is important. Type of plasma is important. Power, pressure, time, dose rate, and the material itself. So there are many variables, and as I'm sure you know, new materials are being invented all the time. So plasma surface modification as a field of study and research is not going away. And I can't really see how AI could easily replace that. AI can help direct the research, but this is hard material science type of work, so good luck replacing that one. Something to keep in mind though, plasma surface modification is often not permanent. You make the surface more wettable, but that can easily go away with time. It's called hydrophobic recovery in the industry. So when you plasma treat something, you also need to carefully pay attention as to how that treatment degrades with time. Maybe often you want to If you're painting something, you want to paint it right away. And some of the reactive species that plasma puts on a surface, the lifetime could be milliseconds, microseconds, or even nanoseconds. So that also is very important to consider, especially for microelectronics or very high precision applications. And of course, it's very important to understand what changes were done to the surface. And in the next video, out of the three, the second video in the series, I'll talk about the water contact angle measurement and why I find it interesting and funny at the same time. If you have any questions, please leave them down in the comment section below. I love answering your questions, especially ones I know how to answer and find interesting. Peace. I'll see you in the next one.